Hello everyone and welcome to 7th grade math module 6, geometry. In this video we're looking at a special lesson on transversals. Our learning goal is to make sure we can identify and solve for angles formed by parallel lines and transversals. While this is connected to our standard 7 GB5, use facts about supplementary, complementary, vertical and adjacent angles in a multi-step problem to write and solve simple equations for unknown angles in a figure. It's not actually, these angle relationships aren't mentioned specifically there, but they are tested on our state PSSA, so it's important for you guys to know these angle relationships now. So we have here a pair of parallel lines and another line that cuts through them. And whenever we have a line that cuts through some parallel lines, we call it a transversal. And when that happens, we end up having some special angle relationships that happen. You guys are already familiar with vertical angles, which are in yellow in this picture. They're just on opposite sides of intersecting lines, and they have the same measure. But when we have transversals, we have some other lines that have the same measure. One of those is corresponding angles. So one example of corresponding angles would be my angles in red here. And the idea with corresponding angles is they're in the same spot on their separate parallel lines. So as a result, they are going to end up having the same measure. So if I just slid that red angle down, it would sit right on top of the other one, and they end up taking up the same space and being the same size. So there is our corresponding angle. We have alternate exterior angles, which, just like the name says, they are alternating which side of the transversal they're on. So it switches from the right on the top to the left on the bottom in orange. And then it's exterior, so it's outside of our two parallel lines. So if I thought about taking my paper and folding it so that my two parallel lines were on top of each other to form a single line, those alternate exterior angles actually would be in the same place as vertical angles. So they still have that same measure there. And then we have our other angles that are equal are our alternate interior angles. So they're the light blue ones there. They're on the opposite sides of our transversal, but staying inside of our parallel lines. And if I slid those to be on the same line and just kind of had those parallel lines, again, folding my paper but kind of seeing through it, they would still be in those vertical positions. We have two other angle relationships here, which you may use maybe a bit less because you can see the equal ones a little easier sometimes. But we have same side interior angles, which add up to 180 degrees. Those are the ones in green. And then we have same side exterior angles in purple, which also add up to 180 degrees. And it's a little easier to see for the exteriors compared to the interiors, but if I again just took my parallel lines and folded my paper so it was on top of each other, either looking at the exterior ones or if I could see through the paper to the interior ones, they would end up being supplementary. So that's how we get that they add to 180 degrees. For the remainder of this video, I'm going to encourage you to pause and try to identify the correct angles and their relationships for the rest of these examples. So in this diagram here, we're going to try to identify first our corresponding angles. Those are the ones that kind of slide and go into the same spots. And then we're going to do our alternate interior. So if I took, I got my two parallel lines P and Q here. So I want to think about sliding sideways from P to Q. So if I slid angle 1 over to Q, it would be in the same spot as angle 3. If I do that with angle 2, its corresponding angle would be 4. 5's corresponding angle would slide over to 7. And 6 would correspond with angle 8. For our alternate interior angles, remember that those are going to be in the inside of our transversal. So I can only really be looking at 2, 6, 3, and 7 here. So alternate then being the opposite side. So if I have angle 2, then the opposite side inside would be 7. And then for 3, the opposite inside would be 6. So what's the whole point of identifying these angle relationships? It's to find the values of angles. So if I had to try to find the value of angle 6, knowing that angle 3 is 56 degrees, we already saw before that angle 6 and angle 3 are alternate interior angles, and those are going to be congruent. So since angle 3 is 56 degrees, that means that 6 is also 56 degrees. For the measure of angle 1 and angle 3, we already saw in the previous problem that they are corresponding angles, and corresponding angles also have the same measure, so all 3 of those angles are 56 degrees. Alright, so here we have 2 pairs of parallel lines, or 2 lines that are intersecting and then another 2 lines that are intersecting, and if we were trying to prove them parallel, we would have to use what we know about the angles to say that they have those correct angle relationships. If they do, then these are all parallel. So we have the angle 5 and angle 6 and angle 7 are all 80 degrees. So if we can find angle relationships that connect them, then we can prove this. So we're going to start with angles 5 and 7. So 5 and 7 here, they're going to be looking at that parallel of P and Q being crossed by S, which would be our transversal in this situation. And they're on the opposite inside of our parallel lines, so that means that they are alternate interior. Then for 6 and 7, 6 and 7 are actually running with S and T as their parallel lines, and Q cuts through it as a transversal. But what angle relationship do we have here? Well, if I slid 7 and 6 from their lines of either S or T to the other, they'd end up in the same spot, so those are corresponding angles. So since we have a pair of alternate interior angles between P and Q, and then corresponding angles between S and T, that means that all of these lines would end up being parallel. What does this video make you wonder about angle relationships with transversals? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.